Good evening, everyone. It's a Saturday evening. It's a beautiful Saturday evening across the Ozarks. But as you are probably aware, jet stream is becoming more active across the plains. Case point, take a look at this. This is the current tornado watch outline. There are three of them in effect right now, stretching all the way from Texas up into Oklahoma, and then another one here through Texas. Two of them actually, and those extend more to the north up into Nebraska. And actually, the weather watches really continue all the way up to Bismarck, North Dakota, and beyond. There have been a handful of tornado warnings earlier, most notably there off to the south of Hayes earlier this evening. There was a tornado reported, a couple tornadoes actually, some rapid spin ups. Since then, it's become more of a severe thunderstorm situation. Now, tonight, what you're looking at is a radar and a combination of that and a satellite. Let me turn the radar off, and you can see the big colder tops of these storms erupting over the plains. And as we go through this the next couple of days, what happens the night before becomes somewhat important to what will happen the next day. So these storms, if they do not progress across all of eastern Kansas and Oklahoma, that actually sets up tomorrow a little bit better. The same will be true for us on Sunday night going into Monday. So we just have to watch what's called the mesoscale. What happens to these thunderstorms and clusters? Do they ever form lines? Do they die away? And where do they end up the next day? Because that has ramifications for where the most unstable air is the next day. So that's what's going on there. Let me turn that off. Turn that off. Go ahead and do the meso analysis overlay here so we can take a look at the jet stream flow. So this is one aspect of it here. So these winds are fairly moderate, certainly good enough for severe weather. And we also have a lot of unstable air. One way to look at that is just to look at the current dew point plot. And you can see dew points well into the 70s across much of the area. And so this is really providing moisture. Moisture provides a couple of things. Overall, it just releases more energy. Everything else equal. It also provides more unstable air. And also moisture, when the temperature and the dew point are very close, it lowers the basis of thunderstorms and makes their tornadic potential go up a little bit. So when you have higher dew points, generally you have a better shot at severe weather and possibly tornadic weather. So what does all that mean for us and for the Great Plains over the next couple of days? Interesting questions. I think severe weather, just like today, is almost a certainty tomorrow and also on Monday and maybe even on Tuesday in parts of the Great Plains. Not much is going to stop that. Let's take a look at a couple of things. First of all, this is a plot of, this is just called a supercell composite. And what it does, and it's a nice thing to just kind of look at with explanation, because a lot of times it'll show maximum areas at night when there may not be supercells around. But when you look during the heating of the day, like here, this is valid tomorrow at 1 p.m. on Sunday. You'll notice that northern Missouri, southern Iowa may get an early round of severe thunderstorms out of this or tornadoes. This would be early on. Well, I mean, we typically think of the late afternoon, early evening as being the maximum tornado time. Another thing that this map reveals that is a kind of interesting things you see on here. These are crossover arrows. So the one that is colored in black is the surface wind, and the one that's colored in blue are the upper level winds. So when there are a crossover, like right there, for example, is a good crossover, that indicates a kind of a torque in the atmosphere that helps supercells rotate and produce tornadoes. So at least initially, that sort of turning or torquing is more prevalent tomorrow up in northern parts of the state of Missouri, southern Iowa, but it does extend back into southeast Kansas as well. And then we go through here, and let me advance this. This is 4 o'clock in the afternoon on Sunday. This is looking at about 7 p.m. Notice the explosion of the supercell composite right there and also through Iowa. And I think I'm going to concentrate my storm chase efforts on this area here. If we try to do both tomorrow, we won't make it, I don't think. So if you choose Iowa, and that, it could pay off. But, that's one of the storm chasing decisions you make. Why do that? Because you'll be chasing the storms with the wind. Whereas if you go down into Oklahoma, if all else is equal, these storms will come at you. It makes the chase a little bit easier. You don't waste as much time driving and worried about how far from home you're going to be. Another thing you can look at too, and then again, I'm just stopping on Sunday. I'll do another analysis here in a minute. Well, let's keep going because I want to show you going forward just a little bit more. This is the model that allows us to go to the next day. So then this is about 4 o'clock in the afternoon on Monday, and there is about 7 p.m. on Monday. Notice that it looks almost exactly the same. Same supercell bubble there, same supercell bubble there. What does that mean for the Ozarks? I wouldn't take the severe weather off the table by any stretch of the imagination because, again, there are too many small-scale processes going on to just rely on this pure model output, which you should never do anyway. But broadly, it focuses on central Oklahoma again. It puts the Ozarks more squarely in the center of severe weather. You'll notice that this crossover thing I'm talking about is pretty prevalent here in southwest Missouri, and the winds, generally speaking, are stronger too. So Monday is a day for us, no doubt about that. And then even when you start getting into Tuesday, here's Tuesday about 4 o'clock in the afternoon. Notice we're still in a supercell composite, although on this day the winds are more parallel at the surface and aloft, which is less suggestive of tornadoes and more suggestive of severe storms, a line of storms. Either way, it's a lot of severe weather to take in. So let me switch to the latest computer model from tonight and just show you a couple more things here. This is the supercell composite from the very latest, and I'll go to the south central sector. By the way, again, kudos to the College of DuPage Next Generation Weather Lab maps. These are fantastic, by the way, and they're out storm chasing today. So here, this is the latest model run for tomorrow. So we'll just take you through. This is again 1 o'clock in the afternoon, and this is the supercell composite. No, it's a little bit different. It's up around Kansas City. Initiation time back to Kansas. Now, if that's true on a storm chase, it would even be conceivable to start there, and I like to do this when I storm chase a lot. I just kind of stair step backwards like this down to where it gets better and better. So that's a possibility for tomorrow, certainly. Let's take a look at that. So as we go to, this is 4 o'clock in the afternoon. Notice northeast Kansas looking pretty good. And then you go, and all of a sudden, again, Oklahoma explodes. Whereas much of western Missouri tomorrow night is looking good. So this is something to be watched very carefully. And so the composite kind of fades. This is 10 o'clock at night, but still the Ozarks, I think, would see severe weather at this time, maybe even including Springfield by that time, very close. And then, of course, Oklahoma has good crossover, good supercell. Another thing we can look at, and this is a kind of a combo product, this is called the significant tornado parameter. And when you start getting these to the reds, like tonight, for instance, it's showing that activity out there over Kansas. Now, a lot of times this will go nuts at night, but the reason you have to discount it sometimes at night is because there is a cooling at the surface that kind of takes away from this potential, and this particular parameter doesn't account for that. Now, here's 1 o'clock again tomorrow. The supercell parameter, or the significant tornado parameter, is getting up to the yellow area, and then red north of Kansas City. That's 4 o'clock. And then northern Missouri, that is 7 p.m. But look what happens between 7 p.m. and 10 p.m. You can see some red showing up there in northern Oklahoma. Now, it eliminates everything where that cap or preventing nocturnal inversion stops thing. But I wouldn't necessarily say that's going to be in effect over Oklahoma. So the chase tomorrow for us, I think, would be into Oklahoma. And again, we'll have residual stuff in Missouri. Notice it's painting in some orange there. This is 1 o'clock in the morning here in the Ozarks, so it's something we'll definitely need to be watching very carefully. So that's pretty much a look at what's going on. Strong jet stream, lots of moisture. It's the first opportunity we've had this season for this, so it's a multi-day severe weather event. And again, I'm going on a single-day chase tomorrow. Contact me if you want to go. We'll leave late morning. Probably target eastern Kansas, and then again kind of stair step our way down. That's one possible scenario for tomorrow, and we'd be back by late tomorrow night. So if you have work on Monday, you can still do this. It's $199 for this, and I really think severe weather is in the bag, and a tornado probability is pretty good as well. And if we have more people in the van, I can work with you. I can work on this price a little bit more. So it's an extraordinary event, and we can also do this on Monday. So I'll have more information for you on this severe weather tomorrow morning.